Okay, so when we left off in the last video, you got to see painstakingly, I think you would agree, how different row operations are used. And I tried to do a side-by-side to show you that it's the same thing we do in systems, of solving systems of equations. Using that elimination method just translates directly to row operations. Now, I want to make sure, again, just to keep with the vocabulary, right? Row equivalent, row equivalent. So the definition of row equivalent would mean that, so you start with, if you start with some matrix, say some matrix A, once you have undergone, once matrix A has undergone a sequence of row operations, right? So you did a whole bunch of these row operations. Well, what the matrix would look like after you've done a whole bunch of scaling and replacement and interchanging, the new matrix will look different, right? It will look different than the way it started, but the solutions are not the same. So row equivalent just means that some sequence of row operations has transformed one matrix to another. The symbol that we use is a little tilde. So this symbol simply means that it's undergone row operations. Okay? Now, so of course, I'm going to, my hope is that you have had time to find a video directions how to use your calculator to RREF, okay, reduce row echelon form. But if not, it's not a problem. It's just at some point in time, I'm not going to continue to do all of those step-by-steps that we did in the previous videos. But that is the algorithm that your calculator is using. So there's two fundamental questions that we care to ask about a linear system. So the first question is, does a solution exist, right? At least one solution. Could be infinite, but does at least one solution exist? Remember how parallel lines never cross each other, right? So parallel lines have no solution to that system. Now, if at least one solution exists, we say that the system is consistent. So is the system consistent? If it is, then at least one solution exists. Now, if at least one solution exists, the next question we like to ask is that solution unique? Right? Is it the only one? So if a solution exists, is it the only solution? That is this solution unique? Recall that I believe in the previous video, we had found that at the point 1, 0, -1, that was the intersection point of those three lines in space. Now, it just so happens that, so for sure, since we found one solution, we know that that system, in the previous video, we can say it's consistent because at least one solution exists. The next question is, well, is that the only solution or are there more? Well, in that case, or at least in the case of the previous problem, that was a unique solution. That was the only solution. Okay. So I'm going to try another one because I want to show you what would it look like to have an inconsistent system. Really quickly, all row operations are reversible, right? That should make sense. So like if you multiply the whole row or equation by 2, well, you can undo that by just multiplying by half, right? So if you were to multiply by 2 and you want to get back to where you started, you can just multiply by half. So wherever we end up, we can always get back to where we started by just the reverse operation. Okay, so let's read example 3, and let's pay attention to the wording, because the wording will get you in this class. So it says, determine if the following system is consistent. Well, at this stage, it's pretty easy, but as time goes by, it's going to be hard to remember that consistent translates into at least one solution exists. Okay? Now, in this class, we don't want to go through and solve this system algebraically. It's not too hard, but it is time consuming. I'm going to go ahead and turn this into an augmented matrix. So this would be 0, 1, -4, 8. I got 2, -3, 2, 1, 4, -8, 12, 1. Okay, and this is a 3 by 4 matrix. Okay. Now, at this stage, either you have to go through all those row operations, like we did in the previous video, trying to get zeros here and ones here, or at this stage, if you can, if you would have had time to research how to do RREF, how to reduce row echelon form on your calculator. There's a difference between REF and RREF, okay? So reduce row echelon form is going to be your go-to, because that's going to get you right to the solution. So will you do me a favor? If you had time to look this up, beautiful. If you haven't, can you just pretend for just a second that you know what buttons to press to go from this matrix to this new matrix? Are you ready? So let's assume that you were to go through and actually your RREF is going to look different than mine. If you don't mind, my sincere apologies. I'm going to have to go in and do this. Maybe I'll just do this in real time. It does, not that it really matters. I don't really edit anything. So this is a 3 by 4 matrix. I'm going to put everything in. You just have to listen to me mumble for a little bit. 2, 1, 4, -8, 12, 1. Let me just make sure I have inputted everything into the matrix. Okay, 0, 1, -4, 8, 2, -3, 2, 1, 4, -8, 12, 1. Okay, so now I'm going to do that RREF. RREF, so second matrix, enter. Okay, so at this stage, this is what, if you were to use that operation, reduce row echelon form, this is what your calculator screen should look like. Okay, and now comes the part where I need you to pay attention, take notes. So right here is enough information for you to determine whether the system is consistent or not. Okay? And I want you to translate, we want to take a look at this last third row, this third equation. And there's a built-in contradiction here. Notice that the left side, I'm gonna draw attention to here. There's a built-in contradiction. Notice the left side, 0x sub 1 plus 0x sub 2 plus 0x sub 3. They represent your variables. But notice that somehow you're supposed to add up a bunch of zeros and arrive at 1? No, that doesn't make any sense. In fact, this is just like parallel lines have never crossed, so there's no solution. This is telling you that there is no solution to this system. In other words, this system is inconsistent. Not even one solution exists. Okay? So keep in mind that this is the way your calculator would tell you, say if you had parallel lines that never crossed, there's no solution. Your calculator is trying to tell you information like that. Okay, so one more and then we'll go ahead and conclude this first section. So, of course, I love technology as much as anyone. But many of the questions that I'm going to ask you, and you're going to be asked on your homework, you're not going to immediately be able to just plug it into your calculator and press some buttons and get to a solution. I think, let me see here. I think I'm actually going to punt for just a second because my apologies, I have one of my family members needs me for a second. So I think I'm going to punt and then I'm going to come back in the next video. Either I'll do this problem or I'll do one very similar to it, but nevertheless, we'll conclude and we will reconvene in another video.